Imagine you are trying to have a real-time conversation with someone who is on the other side of the world. Even with the fastest connection available, there is an unavoidable slight delay in your communication. This very same kind of delay, which we call network latency, constantly affects our digital experiences every single day. It is a critically important factor in determining how quickly our online applications and digital services respond to our commands and interactions. Edge computing dramatically reduces this pervasive network latency by physically moving and positioning data, processing and storage capabilities much closer to where the data is actually generated and to the end user who consumes it. Instead of forcing all data to travel extensively to a distant, centralized cloud server for complex processing, many essential tasks are instead handled right at the edge of the network, locally and efficiently. The fundamental and primary reason for this significant reduction in latency lies in the direct minimization of the physical distance that data has to traverse. Every single millisecond, or even microsecond, of travel time genuinely counts in modern digital interactions. When data is required to journey across vast geographical distances to reach a central data center, perhaps thousands of miles away, and then make the return trip back to the user, that entire round trip takes a considerable amount of time. This cumulative time delay is directly influenced by the immutable speed of light and, perhaps more significantly, by the sheer number of network hops or intermediate routers the data must intelligently navigate through. Edge computing strategically deploys smaller, more distributed data centers or highly capable computational nodes. These are placed much closer to the specific locations where the data is either enthusiastically generated or actively consumed. This innovative approach effectively shortens the digital journey for the data, bypasses a multitude of intermediate network devices, and thus eliminates many potential points of delay. This localized, on-site processing capability invariably means much quicker response times, culminating in a far more immediate and satisfying user experience. For a wide range of practical applications, this means that actions you take on your personal device, such as the rapid click of a button in a fast-paced online game, or the immediate reception of critical real-time sensor data from an industrial machine, are processed with remarkable speed. Rather than experiencing a noticeable wait for a response from a distant server located hundreds or even thousands of miles away, the required computation can now occur instantaneously at a local network gateway, a nearby cellular tower, or within a micro data center situated just a few short miles down the road from you. This significantly enhances the responsiveness and efficiency for numerous time-sensitive applications, including augmented reality, virtual reality, autonomous vehicles, and critical industrial Internet of Things operations. A particularly insightful and important concept within the realm of edge computing is the significant reduction of what we call backhaul traffic. In the traditional, often older, centralized cloud computing models, a massive amount of data, frequently in its raw and processed, and therefore very large form, is continuously sent to distant central data centers for all processing. Edge computing, through its clever and efficient design, drastically reduces this burdensome backhaul traffic. It achieves this by processing the data locally at the edge, meaning only filtered, highly aggregated, or truly critical insights and results are then transmitted back to the core cloud infrastructure. This ingenious strategy not only dramatically cuts down network latency but also proactively optimizes the utilization of valuable network bandwidth. Furthermore, it often improves data security by processing sensitive information closer to its origin, reducing its exposure during long-distance transit. By intelligently distributing computational resources and purposefully shortening the physical path that data must travel, edge computing fundamentally empowers applications with near-instantaneous responses. This creates a seamlessly smooth and remarkably efficient digital interaction for both human users and interconnected devices across the globe. Ultimately, it profoundly transforms our entire digital landscape by making it inherently more responsive, agile, and effective, irrespective of geographical distance or network congestion, truly bringing the processing power closer to the point of need.
If you love understanding how the web works, like, subscribe, and stay connected with us.